Chapter number 9, Energy. Lesson number 4, Potential Energy. Textbook page number 148 to 149. And lesson number 5, Kinetic Energy. Textbook page number 150. In these lessons, we are going to learn about the two types of mechanical energy. They are potential energy and kinetic energy. So let's see what is potential energy and what is kinetic energy, and also how to calculate potential energy and kinetic energy. Potential energy. Gravitational potential energy increases as weight and height increase. We know that potential energy is one type of mechanical energy which depends on both weight of the object and height of the object. Here you can see in first figure number 1, which shows that the blue skier has more gravitational potential energy because he is at a greater height, or the weight of both the skiers are the same, 500 Newton. And now have a look at the second figure, which shows that both the skiers, the red and green, are at the same height, but the difference is that they have different weights. The first one, the red one, has a weight of 500 Newton, while the second green one has a weight of 600 Newton. So that's why there is a difference in their gravitational potential energy. The one which has more weight will have more gravitational potential energy. Okay students, now let's see how to calculate potential energy. Calculating potential energy. The gravitational potential energy of an object is potential energy is equal to mgh, where m is the mass in kilograms, g is the acceleration due to gravity, that is 9.8 meter per second square at the surface of the earth, and h is the height in meters. So if we have these values, let's substitute the values in the expression and find out the potential energy of an object at a particular height. And we know that the unit of energy is joules. Okay students, now we have the second type of mechanical energy, which is kinetic energy. Kinetic energy increases as mass and velocity increases. It means that mass and velocity are the two factors affecting kinetic energy. So let's have an example here shown in this figure. The first one shows that there are two balls, a big one and a small one, but both balls are moving at the same velocity. It is mentioned here that they have equal velocities, but still there is a difference in their kinetic energy. You can see that greater mass means greater kinetic energy, less mass means less kinetic energy. It means that if two objects are moving at equal velocities and if they have different masses, they will have different kinetic energies. Like that, the second figure, which shows two balls with equal masses, but the two balls are moving at different velocities. So the ball which is moving at a greater velocity will have a greater kinetic energy, and less velocity means less kinetic energy. So kinetic energy of an object depends on both mass and velocity. Okay, now let's see how to calculate kinetic energy of a moving object. The kinetic energy of an object is Ke is equal to half mv square. Kinetic energy depends upon the mass and the velocity of a body. If velocity is 0, then kinetic energy of body will also be 0. Okay, so if we have the values for mass and velocity of an object, we can substitute the values in this expression to find out kinetic energy, and the unit is joules. Okay, now we have calculating mechanical energy. Here is a question based on the graph given here. The graph shows the energy of a diver. Graph shows kinetic energy in joules and height in meters. The question is, using the graph, find the kinetic energy of the diver at 6 meters, then calculate the diver's potential energy at that point. We know that from the graph it is clear kinetic energy is about 2000 joules and potential energy is about 3000 joules. Thank you for listening. Have a nice day.